was that? Thank you for the ice cream. Yeah, glad you guys enjoyed all the ice cream that I brought today. All right, cool. So looking at this, here's our bell ringer for today. And as we see it, you guys had a couple minutes to look at it, and nobody felt super confident. It's a tricky problem, but again, I just want to stress whether we've done exactly problems like this, we've done all the tools. So first thing that I would do if we have the sketch in front of us, especially, is this is the graph of what? So careful. Are you sure? The graph of a twice differentiable, which means I can differentiate it twice, function f is shown. This is f. Okay. Now, I'm going to be drawing a bunch of stuff that is just to help us think out. You can draw it if you want to, but you don't have to as long as we conceptualize it. What does f prime tell me about this function? Okay, so the slope is positive everywhere. Now, if I start looking at that, and I like that you said slope, I'm just going to put a couple of them. Now, as I work further to the right, do my slopes get bigger or smaller? Smaller. So what I see right now is that my first derivative, f prime, it starts kind of big, and it's still positive, but it's working its way down. So like right here, let's just estimate. What is this slope? I know there's no scale, but give me any number. Could I say 5 just for fun? If it were 5, what's this one? The slope. Maybe 4. And this one? Definitely not negative. 1. Believable? So if I just think about what does this look like, I see that here's where the slope was 5. So I'm just going to plot this point up here. And I'm going to have to undo everything. But this point here was where the slope was about 5. So I'll just plot that point, something comma 5. And then the slope here we said was like 4. So maybe it's a little smaller. Then the slope here all the way over here was like a 1. And the slope here looks like it's getting close to 0. Would you agree? Now, I don't know if it actually hit 0. I can't tell, but I don't know. It's kind of close. These points are x comma slope of f. Now, that can be like, that's an ugly way to write it. It's easier to say this is x comma f prime of x. Each one of those purple points. And I'm just estimating it. So I think that it probably does something like this. And it's going to be a smooth curve. I'm not going to hit it as a smooth curve here, unfortunately. Okay, that purple graph that we just had was f prime. Do you guys agree with it? Have I lost anybody on how I got to f prime? Okay, now if we look at this, we're asked to do a comparison. So right off the bat, the first question, what's bigger? F of 1, which has a value of what? 0, or, and I erased the example so you might not remember, but, or this point right here. Which one's bigger? This point or this point? F prime of 1 is bigger. So right off the bat, I'm just going to look at my multiple choice. I know that f prime of 1 is bigger than f of 1. Maybe. That one could work. F prime of 1 is bigger than f of 1. Maybe. This one could work. Can this one work? No, f prime was bigger, right? So you're garbage. F prime was bigger, so maybe this one works. Garbage. Are we cool with how we just eliminated 40%? Okay, so let's keep kicking. Now, pretend as though we can't even see this black graph at this point. And we're just going to repeat that process. If I want to think about the derivative of this, and notice, I don't even have to say the second derivative. I'm just thinking about the derivative of this purple graph. Okay, I'm going to use red for this one. If I check the slopes, let's just get an estimate here. Estimate this slope for me. And I'll try to make it a tangent line. There we go. -3 sound believable? And all of a sudden, maybe I want to do it right here because that makes more sense. Could this still be -3 though? So I now know that at 1, the slope is -3 roughly, some negative number for sure, right? So I'm just going to plot my red point, which is f double prime, here. Now, I could do it everywhere. Is this slope getting more negative or less negative as I go? Less negative, so it's getting bigger, which is a weird idea. But if I wanted to think about the whole derivative, I assume if I kept going, it'd be steeper still. So I assume that my second derivative is going to do something like this, is my guess. It's getting closer to 0. Eventually, it might change, but we can't really tell. What I can tell is that F double prime of 1 is what? Like, not a number, but you can give me something about it. Less than the others, or negative, but those are both true. So based on these, what's the biggest? F prime of 1, F of 1, or F double prime of 1? F prime of 1 is the biggest, and what's the smallest? F double prime of 1. So I'm just going to check. Prime is the biggest, double prime is the smallest. Ooh. Okay, F prime is the biggest. And it's weird because it's written as greater than. It's like the order is funny in my head. This is the biggest, this is the middle, and this is the smallest, right? Boom. Did you get the answer? Did you guess it or did you get it? Love it. Awesome. Good on you. Cool. Extra scoop. Cool. All right. Doable. Kind of out of left field, but I really like the idea of just saying, hey, here's a completely random problem that we can do, but we haven't. We're going to keep doing these. I like the bell ringer for AP bell ringers. Cool. All right. Questions before we kick back to yesterday's stuff? Okay, I'm going to control Z all of this because, nope, I'm just going to zoom out and we'll pause it so they don't have to watch me do that. So, for our applied problem today, and it's not too late to change if you want to, but I think that yesterday, based on stuff, you primarily all said we should probably do the medicine one. Like, that's a more interesting application. Okay, so do you guys have textbooks with you? Fern does. JJ does. Okay. Mickey and Angel. Anybody that doesn't have a text, I don't need to call you out. Just scoot your desk, share with somebody, so you can read the problem. Okay. So on this, I'm going to get the very basics of this written out, or at least up on the screen. My projector was not working, or my camera. What microphone am I using? Bizarre. My video is about to stop. And I have no idea why. It's not stopped yet. Weird. So, sorry, it's... Okay, so I'm going to say volleyballers or Sean, anybody who's absent, we are looking at an example. We're just going to do one example today, and then I'm going to give you guys time to work on some stuff. But our example is going to be example 6 on page 296. Now, I try pretty hard to make sure that we do examples that are outside of the textbook so that you have additional ones. I don't have another nice applied thing, but it's cool to see how it works. So, from physics, we know that the volume, or we're told at least, the volume of a fluid that flows through a pipe is related to the radius of the pipe and the difference in the pressure at each end of the pipe. Okay, now first little weird part there. Air is a fluid. If you don't recall that, air is a fluid. It's not a liquid, it's a fluid. Okay, the same way that particles move through air is the same way that particles move through water, except water is more dense and it's a thicker fluid, more viscous, harder to move through. Same idea though, like birds can fly, just like fish can swim, buoyancy and all that good stuff still applies. So as we're looking at it, all that I know for sure is that the volume, just kidding, yeah, the volume of the fluid, we're told in this problem, is K PR to the 4th, where K is a constant, and I'm just going to jot down everything that not words and stuff, but K is a constant, so I'm just going to write that a little bit differently. I'm going to say K is a real number, that's all it means. Okay, and then beyond that, R is the radius, equals the radius, and P equals pressure. Okay, it kind of bugs me that they don't use a capital P, but whatever. All right, so we're all cool, I think. Like, I'm just writing down the basics. Now, if you haven't read it yet, or if you have even, maybe, I don't know. Coughing is caused by increased pressure in the lungs, accompanied by a decrease in the diameter of the windpipe. So if I have a higher pressure in my lungs, but my windpipe, like, closes a little bit, which just muscular contractions make that happen, a cough occurs. Okay, deal. Okay, they give us a picture that's, it looks like a cylinder to me, but the radius decreases with higher pressure according to this formula. So we have at first an ugly little formula. They say R naught minus R equals CP. And we'll have to dig out what this all means, where R naught equals the radius of the windpipe when no difference. So we'll say resting radius, like we're not coughing. And C is, once again, a positive constant. So I'm just going to say R plus. So it's now a positive real number. So I'm just trying to make sense of everything. I don't love the not or sub-zero notation, but it's pretty common in physics. Last year, if you recall, because I don't, so we use V sub I or V naught in physics. We use sub I. So sub I or sub-zero, same thing. It's just where do we start? Okay, so there's that. And then they give us the volume, which we already have. We want to find the radius R. So find R. I'll write it here, and we'll start working to the other area. Excuse me. Find R, the radius that allows the most air through. So I'm going to rephrase that. Instead of saying find R that allows the most air through, the most air, what measures in this equation the amount of air? Volume. So we're just trying to find R that produces maximum volume. Now, that little change there, in my mind, it makes this problem go from like, what the heck, to, oh, okay. Because what did we spend all the first part of the section finding? So give me some function. We use a little bit of calculus to find the what? The extrema. And is a maximum an extrema? So all of a sudden we can see that, okay, this does relate directly to what we've been doing. All right. Now, beyond that, they say that we restrict R so that it's between R naught over 2, or half of the resting radius, and the full resting radius. Cool. So if we look at this right off the bat, P is a constant, R is the radius, and, sorry, P is a pressure. So this is a variable, and R is a variable. It varies. We all agree with that. Why am I even referencing that these things vary? Any idea? Okay, so I'm going to preface that with the first question then. How do we find the possible places where my maximum will occur? At my what? Could be at the endpoints, or critical values, critical numbers, right? Whatever one you want to use. And what are critical numbers? It's where f prime is, or v prime in the situation, is not defined, right? Okay, so here's what I'm thinking. If I were to just immediately jump in and try to find v prime, I have two variables, which means I'm going to have implicit differentiation and a product rule, and it's going to be yuck. Or maybe we just make it so there's only one variable. Maybe we can do that. Now, as I'm looking at this, which one don't I want? Do I not want P or do I not want R? I don't want P because I need to find the R, or the X value, same thing, that will ultimately give me my maximum. So we need to get rid of P somehow. So the new question in my head, and I haven't looked at the text, and if you guys are following along, I assume they're doing something similar. I've not looked at it even other than to write the problem. My thought initially is, how can we write V, that volume, and I'm going to just write it as V of, right now it's in terms of pressure and radius, right? I only want it in terms of what? Radius. So instead of all those words, it's the same thing as saying, how can we write V in terms of R? Or, more nicely, how can we write V of R? There's no P for pressure here. Huh. Well, I think this looks like a pretty convenient option. Like, they gave it to us. There's some restriction. Does this allow me to solve for P in terms of R? I think so. Right? Like, I just divide both sides by C. So I'm going to make note of that. This, and I'm sorry for those of you watching the video, you couldn't see what I was pointing at. This thing allows me to solve and get rid of P in my equation. Like, let's just try it. So if we do that, my velocity instead becomes, we still have a K, and then what do we just say we're going to plug in for P instead? If we solved it, because we didn't actually say it. R naught minus R over C. So there's my pressure. And I'm still multiplying it by R to the fourth, right? Okay. Now, when I look at this, I don't know if I would say it's nicer necessarily, but it certainly only has R as a variable here. And that can be misleading because somebody's going to look at this and go, whoa, no, it also has a K and a C. But remember, what are these? They're constants. So immediately before I do anything else, and I'm just going to take a little step, can I write it so it's very clear that these are constants? Can I rewrite this expression so that it's a little bit friendlier to think about? Before I expand on what I mean, I'm going to say, talk with your neighbors. How can we write this so that if somebody's going to make a mistake with constants or anything like that when they do the derivative, how do we avoid that? Is the essential question. What do you think, Abigail? I could hear you talking. Brackets around the parts with R. That's fair. And this next one, just so you know, this is a total Holloway line of thought. It's not like required or anything, but because I watch people make mistakes with constant multiples, pretty common that I try to rewrite these. K is a constant. C is a constant. In my head, this is the next natural line. R naught minus that naught is way too big. So it's the erase. R naught minus R times R to the fourth. Now, it's a very subtle change, and I don't know if this is really true or not, but I think and I hope that this makes it very clear that this is my constant. Okay, so now what? Say it again. What's R naught? We should probably work that out. I'm getting paid no matter what, just so you know I ain't in a rush. What do we say R naught is? So if we're measuring somebody's windpipe and their resting radius of their windpipe has a certain length, does it change? Or is their resting just going to be their resting radius? It's going to be a constant too, isn't it? Okay, so maybe that's pretty convenient. Where do you want to go with that? So I can't just quite move it out front, right? Because these parentheses are telling me something. Could I distribute these? Or we could distribute the R to the fourth so that we get a constant with it. I don't care which way we go. What does your gut say? Are we distributing from the left or distributing from the right? From the left? Okay, I'm fine with that. So let's just see what shakes out. And I know we just pulled the constants out, but I don't think we're hurting anything by doing a little bit more. Maybe it's KR naught over C minus KR over C times R to the fourth. Don't know that I love it, but that's okay. If we had, and purely like don't write this until we decide, if I had gone from the right, I would have had this instead. K over C times, it would have been R naught R to the fourth minus R to the fifth. Like these were my two options that we had. On this one, if we think about differentiating, we could distribute this in if we really wanted to, and ultimately they're going to be the same, right? It's just which one's easier to think about as we do the problem. In my mind, this is a product rule, and I'm going to have to use a product rule. In this one, do I have a product rule? On the second one, I don't, because even though it looks like I certainly do still have multiplication, but it's a constant, which we don't have to worry about. That's just constant multiple that moves to the front. I like the yellow version more. Now, both of them will take us to the right spot. The blue one here is a product rule, which is fine. We can deal with it. But I think I would rather just not deal with the product rule, if you guys are cool with that. Okay, so right now, I want to continue with this one, with the understanding that both work. The blue one, though, is an uglier derivative. So I'll just make a note, just so that we can have it. Both work. But this one is uglier, and specifically because it has a product rule needed. because we need to find our critical values or critical numbers by taking the derivative. Let's think about what's going to make the derivative easiest for us. Okay, and I'm going to look at the book now just to see if they did the same thing. So they wrote in the end, they said that it is pretty much this. We factored out the k over c, but we get the exact same thing. Awesome, we're on a good track then. If you'll notice on their solution, like we've talked through a lot of it because the conceptual part is much more important than the math and being able to do it. But do you agree that what they have written is exactly what we have written? They just distributed that through one more. Now, do you know where I'm talking about? I can't tell based on the look on your face. Okay. Do you really? Okay, so just to be like, just so it's really clear, thank you for giving me the itch on there. Okay, so now that we have this, critical values are going to happen where? At one of three places, and I'm going to give you two of them for free. The left endpoint, the right endpoint, or critical values, where the derivative is 0 or undefined. So here's my function v, and I'll just go ahead and write v here. Could we differentiate it? I can. I want you to. You find me v prime. And again, the book has it. Don't just trust what the book says. I'm sure they're right, just for the record. But I want to make sure that you can do the derivative. We have a slightly different form. We're going to get a slightly different derivative. Cool. I'll meet you guys back in a minute. Here's my derivative. No product rule, no nothing. Constant multiple moves out front. And then this is just a constant times r to the fourth. So the 4 moves out front and the power drops. Same thing happens here. 5 out front. It's just a power rule. Okay. So now here's the issue. We need to set this equal to what? So 0. Okay. So checking this out. If we set it equal to 0, and I'm going to have to slide this way. If I set it equal to 0, I know what I see first, but I'm not sure what you guys see first. Obviously, I can't see your minds most of the time. What do we do? How do I set that equal to 0? What do you want me to factor? Because I agree, just so you know. Factor in r cubed. I'm cool with that. What do you want me to do with that k over c? Can I just multiply both sides by c over k and get rid of it? It's just a constant. It's no different than if I had this, and don't write this, but if I had something like this and we were trying to factor it, to solve it, could I just divide both sides by 2 right off the bat? And it looks nicer, it's easier to deal with. It's the same thing, but it's just nicer. Same thing. Let's divide both sides by k over c. So when I rewrite this, I'm not even going to include the k over c. I'm just going to let them fall out. So I'm going to do exactly what Bea said, though. She said, let's factor. And she said we can take an r cubed out. What would it leave behind? 4r naught minus 5r. Okay, we now have a wonderfully nice factored version of this to find the critical values. Can you tell me either of the critical values? And I'm going to physically write it, crit val. So r equals 0 there from this, right? Because r cubed equals 0. R must be 0. This one's a little bit uglier. To solve for r, and I'm going to actually show the scratch work just in case, but if I try to do this, 4r naught minus 5r, I think most of you can probably solve it in your head, is my guess. But if you can't, it's totally fine, right? Help me solve this for r. What do you guys do first? I'm going to move the 5r to the other side. 4r naught equals 5r. Therefore, I think we can probably all see it now. What's r? 4r naught over 5. Okay. Now, as we look back, there's a couple things that I did not write down about the problem that I'm sure I said it, but we didn't talk about it. They restrict us somewhere. Where do they restrict us? And you're going to need to look at the book in front of you. It's not up on the board. But they tell me something. And I'm looking at the top of page 297. Okay. So that statement, and if you guys don't see it, it's the third line on page 297. Restrict R so that 0 is less than r naught over 2 is less than or equal to r is less than or equal to r naught. So that's an ugly statement. The 0, I think it's important to include it because if your throat has a radius of negative, that's odd, right? What are the endpoints out of that statement? So 0 and r naught is natural, but check this. Are you ever going to get your radius of your windpipe to really be 0? Like if it's, like obviously there's situations where it could, right? Like I'm having a huge allergic reaction or something. Okay, but check it out. It's 0 is less than that, right? So if I said what is r stuck between? Just r, because that's what we're really looking at. I agree with the r naught on the right side. But what about on the left? R naught over 2. Like, and it's misleading, but that's where r is stuck between. Those are my endpoints. I'm never going to be less than that. Okay, so when we're looking at this, we just now need to decide. We're going to check v of, and we're going to do it with 3 values. What was my left endpoint that we just worked out? R naught over 2. We're going to check v of, not 0, right? We're not going to include that one because it's not within my endpoints. What's the next critical number? Dang it. What's before the next endpoint is what I meant to ask. Good, and it's the other critical value. And the other endpoint is R naught. Okay. Do we have the capability of calculating this? Now, here's where it's going to get wonky. Do you want to play the calculator game, or are we okay with saying we should probably play the calculator game? Let's play the calculator game. Okay, so we'll have you grab calculators, and we'll see if my smart camera works here in a second. Here's our function, v. All of these are different versions of the same function. You don't have your notes. Okay, of these 4 choices, and I'm going to just label them A, B, C, and D, which one do we want to plug into? And I guess there's one more that has P in it, but we don't have that, so we probably shouldn't use that. A, B, C, or D? Which one is going to be the easiest to plug into? In your opinion. And there's not a right answer. I know what I think. Which one do you think, Rafa? Delta? What do you think? Abigail? Angel? Are you just saying that because everybody else is saying it? If we all jumped off a bridge... Okay, so that's just me being silly, right? Okay. So I agree. D is the one that I think is the easiest. I don't really care which one you plug into, but let's just see what happens. And with a calculator, I don't know if this is really going to be that convenient. But there's a K over C, and we'll see like in a minute if we can and when we will use our calculator. We have R naught times, well, if I plug in this for R and I take it to the 4th power, can you tell me what we're going to get? So I'm trying to plug into this R right here, but I'm plugging this in. What's R naught over 2 to the 4th power? To the 4th over 16, right? And you may jump just to calling this R naught to the 5th. Maybe. Okay, minus, and this is just once again going to be R naught over 2 to what power? So can I just do to the 5th over 32? I've lost somebody, I'm almost sure of it. What you should have, and what I should have, is this, right? Because that's r squared, or r to the 5th, I'm sorry. But I'm just taking a little step and saying, well, that's to the 5th, and 2 to the 5th is 32. Okay, so let's see here. It's ugly, but we'll be able to deal with it. This is k over c, and that's r naught to the 5th over 16 minus r naught to the 5th over 32. Well, I'm just going to call this 2r naught to the 5th. I'm making a common denominator. Please tell me if I'm going too fast with the algebra. I think I want to call this 2r naught to the 5th over 32 minus r naught to the 5th over 32 gives me r naught to the 5th over 32. Okay, are we all on the same page? Okay, So we have this value for now, and it's kind of ugly, but we'll deal with it. Pause. And maybe we don't need calculators, and I was just totally wrong because I was thinking we're going to have something to plug in, but we don't have any values, right? Okay, I'm going to give you guys a second. I want you to do the middle one. I'm going to do the last one. Don't just look at the book. I want you to actually do it. Get the practice with the algebra. And I'm going to pause here. And volleyballers, if you're watching this, pause it now. Do the middle one. And when you're done, resume. And you'll see the middle and the bottom. Okay. So the numbers are ugly. And I don't know about you, but I'm not super great at this next part. Can you tell me with confidence which one of these is the biggest? Can you tell me which one's the smallest? Okay, so that one's easy. So that's 0, right? That's the smallest. Now, out of these ones, let's just check here. R naught doesn't change, does it? So all I really need to know is K over C is going to be the same for all of them. So that and that are the same. And I'll point here so we have the right point. This and this and this are all the same number, and that. Okay, so what's the coefficient on this R naught here? 1 over 32, and I don't know what's bigger, 1 over 32 or 256 over 3125. I'm not sure. My gut says this is probably bigger, although I don't know that. This is bigger? What, so like you can verify, I'm going to cheat with the book. This comes out to be about 0.031. 0.031 for that one. And this is 0.082. And now there's, of course, there's the K over C and the R naught to the 5th. There's a K over C and there's an R naught to the 5th. Which one's bigger? Knowing that this and this are going to be the same, what makes it bigger? Multiplying by 0.031 or multiplying by 0.082? Can we all agree that this must be the bigger one? Okay, now for this, gross, cool problem, really ugly calculation, but it's whatever. So the actual question, it said, let me see, I'm even trying to remember what we're answering. What radius, find the radius R that allows the most air. Most air is highest volume, right? The highest volume, which is the same as the most air of air, is present when the radius R equals what? 4 R naught over 5. And I'm trying to see if they give us any units anywhere. They don't. What do you think they measure the radius in? For an air pipe? Millimeters, probably. I'm just going to say units because they didn't specify. Now, I'm not going to make us write it, but what is the maximum amount of volume that occurs? And I'm not even going to make you say it. Can we all agree it's this? Like, it's gross. KR naught to the 5th over C times 0.082. Ugly. Now, who do you think might use this? When would anybody use this? Doctors. What kind of doctor? So for real, like an ENT, ear, nose, and throat, for sure, it's going to be them. My first thought is anesthesiologist and intubation stuff. So when somebody's there, like creating the tubes that you shove down into people's lungs, which that sucks, you need to know, like, how does the throat change and what does it do? How much air is coming in? Because what happens if you pump too much air into somebody's lungs? You pop them. Or if their lungs don't pop, you put a whole lot of pressure on the windpipe and maybe you pop the windpipe. And there's all sorts of issues. This problem, it's pretty out there as far as the ones that we've done. Like, it's cool to see it's applied. It's way beyond anything that we would be applying in our everyday lives at this point. But for somebody out there who eventually becomes a surgeon, or maybe you're trying to make a new pipeline and you want to know the pressure in the pipe because you don't want it to burst and spill oil all over, you know, the pristine Anwar. Or you're doing, like, whatever. There's a million situations that this could apply to. This is just one of them. Cool. That's a big one. I don't anticipate that you would see a problem that in depth and that applied on the AP test. And we don't really do that many problems that are that applied, but it's nice when we get to a point where we can say, like, hey, Here's a real true application problem that's not just lame example of, I want to build a triangular table or whatever that other ones that you get in geometry and stuff are. Real world application immediately. Okay, we got 6 minutes for which you can just go ahead and continue working on your assignment or chill. I'm not going to give you a hard time about stuff. Baller. Good luck, Raiders.